Hello one and all, welcome to Hacker Channel. In the last video, we talked about the OSI model and discussed the function of each layer, and also the protocols that used on it. So if you didn't watch it, you should do firstly, then come back again. In this video, we will discuss the TCP IP model and delve into its layers. TCP and IP are the heart of this model. TCP stands for Transport Communication Protocol, and it is used in the transport layer, where IP stands for Internet Protocol, and it is used in the Internet layer. Beside transport and Internet layers, TCP has another two layers. One of them is the user interface, and it is called the application layer, where the other one is a linker, an interface for the physical and hardware components. It is called the data link layer. Those four layers together forms the TCP/IP model, which is the foundation of the Internet, mobile networks, network security, telecommunication, cloud computing, Internet of Things, and others. Now let's have a quick review for the sending and receiving processes on this model, which is pretty much the same as the OSI model. In the sending process, our first station will be the application layer. Its job is to take the data that will be sent from that certain application or web server, then encrypt and encode it. After that, it will pass it to the transport layer. Transport layer will separate this chunk of data into several small pieces, then add the source and port destination on it to form the data segments. Data segments will be delivered to the Internet layer, which will add the IP addresses of the sender and the receiver on the message header to form the data packets. Then it will choose the best path or route to deliver this message and pass it to the link layer. Link layer will add the MAC addresses of the sender and the receiver to the header and the frame check sequence on the trailer to form the data frame. Then it will convert this data frame into binary sequence. After that, it will turn it into physical electromagnetic waves, then send it through the air as a radio waves, or through optical cables as optical signals, or through electrical cables as electrical signals. Now let's talk about the receiving process. The electromagnetic signals will be delivered at the receiver's link layer, which will inverse the sending process and transform it into data frame. Then it will check for the MAC address and FCS. Make sure they are both right, then pass it to the Internet layer. Internet layer will check for the IP addresses, emphasize it is the right destination, then pass it to the transport layer. Transport layer will check for the ports on the segments header to determine at which application or web server our message will be displayed on. Then it will reassemble all those data segments together in order to form the intended original data, then pass it to the application layer. Application layer will decrypt and decode the data, then represent it on that certain application or web server. Now let's mention the protocols that can be used on each layer of this model. Application layer will use protocols like HTTP, HTTPS, FTP, SMTP, and other protocols for different applications or web servers. In the transport layer, TCP and UDP will be used, while in the Internet layer, IP, ICMP, and IGMP can be used. And lastly, Ethernet, Wi-Fi, Bluetooth, USB, and other protocols or specifications can be used at the link layer. So that was all for today. Thanks for watching, and don't forget to support us with like, share, and subscribe, and see you in the next one.